Hello there, and welcome to the Sleepy Space Channel. The list of worlds where a human being could actually live is shorter than the night sky makes it look, and stranger than you might expect. On almost none of them is the surface the place to stand. The Moon offers ice in craters the Sun has never touched. Mars offers rooms that must be buried beneath its red soil. Venus offers cities that would float high above an inferno, and the moons of the outer planets offer oceans hidden beneath their ice. Tonight we travel slowly outward through every one of them, from the nearest shore to the faint worlds that circle other stars. If you find these journeys through the night worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of these distant worlds is anything you need to reach tonight. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away behind you until the far worlds feel less like a destination and more like quiet company in the dark. Let's begin. There is a quiet, unsettling fact hidden inside every dream of leaving Earth, and it is worth stating plainly before we begin. Almost nowhere else in the universe wants us. The worlds beyond our own are not waiting rooms with the lights left on. They are places of hard, cold, thin air or no air at all, and radiation that falls without mercy from an open sky. And yet, scattered across the solar system and beyond, there are a small number of places where a human presence could take hold and endure. Tonight, we are going to visit them, one after another, slowly and without alarm. The word we will keep returning to is colonize, and it helps to loosen it from its more dramatic meanings. To colonize a world does not mean to conquer it, and it does not mean to find a second Earth standing ready. It means something quieter and more difficult. It means building a place where people could live and go on living without a constant lifeline back to the world that made them. It means air that can be renewed, water that can be found, and shelter that holds the cold and the radiation at a distance. Measured that way, the question is not which worlds are beautiful. The question is which worlds could keep us alive. Every candidate world will be judged, gently, against the same short list of needs, and it is worth laying that list out now, so the pattern becomes familiar. The first need is energy, because everything else depends on it. Warmth, light, air, and the machinery that makes them all flow from a reliable source of power, whether that is sunlight where sunlight is strong, or the steady heat of a nuclear source where the sun grows faint. Without energy, a settlement is only a slowly cooling shell. With it, almost anything else becomes possible. The second need is water, and water turns out to matter far more than thirst alone would suggest. A world with water is a world with breathable oxygen, because water can be split into the air we need. It is a world with fuel, because the same splitting yields hydrogen to burn. And it is a world that can, in principle, supply itself, rather than wait on shipments from home. When you hear that a distant moon or a frozen crater holds water ice, understand that what it really holds is the possibility of independence. That single resource quietly unlocks most of the others. The third need is shelter from radiation, and this is the need that most often decides the question. On Earth, a thick atmosphere and a global magnetic field turn aside the constant sleet of particles from the sun and from far outside the solar system. We live our whole lives beneath that protection without ever feeling it. Most other worlds have nothing of the kind. To live on them is to put mass between yourself and the sky, layers of rock or soil or water or thick air overhead, and a world that offers such shelter freely is worth more than one that merely looks inviting. The fourth need is a workable gravity, and here every world falls short in its own direction. Too little gravity, held for years, and the body begins to weaken, the bones thinning and the muscles fading in ways we do not yet fully understand. Too much, and every step becomes a labor. The worlds ahead offer a range of partial gravities, from a faint suggestion of weight to a pull far heavier than home, and none of them is quite right. This is one of the honest, unresolved problems of living anywhere else, and we will meet it again and again. The fifth need is raw material, the ordinary stuff of building and growing. Metals for structure, silicates for glass and concrete, carbon and nitrogen for air and for soil. A settlement that must import every screw and every breath is not truly a settlement at all. It is a fragile outpost living on borrowed time. The worlds that matter most are the ones that carry their own materials within easy reach, so that a colony could grow the way a town grows, out of the ground beneath it, rather than out of crates sent across the dark. The last need is simply reachability, and it is the quietest filter of all. A world can hold every other virtue and still lie so far away that no one could ever arrive in a single lifetime. Distance is not a detail to be solved later. It shapes everything, from how a colony is supplied, to whether it can be rescued, to whether the journey there is measured in days, in years, or in tens of thousands of years. As we move outward tonight, the distances will lengthen, and the promise of each world will come more and more to depend on whether it can be reached at all. Hold those 6 needs loosely in mind, and a strange thing begins to happen as we consider the worlds themselves. The most dramatic places, the ones that look like the covers of old adventure stories, often turn out to be the worst homes. And the plainest places, the grey and cratered and forgettable ones, often turn out to be the best. The reason is almost always radiation, not scenery. A world can be magnificent to look at and lethal to stand on, and a world can be dull beyond description and quietly, patiently survivable. We will watch that reversal play out more than once. There is one more idea to carry, and it may be the truest thread running through everything ahead. On nearly every world we will visit, the surface is a trap. The place worth living is somewhere else. It is down in a shadowed crater where ice has hidden for ages. It is beneath a few meters of soil where the radiation cannot follow. It is high in the sky above a burning ground, or far below a shell of ice, or sealed inside a slowly turning drum of borrowed weight. To leave Earth is not to find another Earth. It is to learn to make small, careful shelters in the few sheltered corners a hard universe allows. It is worth sitting for a moment with how strange our own comfort really is. We were made by a single world, and made so precisely for it that we notice none of its gifts. The air is exactly breathable. The temperature holds within the narrow band our bodies need. The ground carries us at exactly the weight our bones were built to bear, and a field we cannot feel turns the dangerous particles aside before they ever reach us. We call all of this ordinary because we have never known anything else. Only when we look outward, at the worlds that offer none of it, do we begin to see how rare and how finely matched our home truly is. Every world ahead will fail to match it in some way, and the art of settling them lies in deciding which failures can be answered and which cannot. A missing atmosphere can be replaced with sealed walls and stored air. A punishing cold can be met with warmth and insulation. Radiation can be buried beneath rock. But some shortfalls run further than engineering can presently reach, and the faint gravity of a small world is chief among them. We can build almost anything except a stronger pull, and so the question of weight will shadow nearly every world we visit, unresolved and quietly important. There is one more thing worth saying before we set out, about the spirit of the journey itself. This is not a race, though it is sometimes spoken of as one, and it is not a flight from a doomed world, though that fear is sometimes the reason given. It is better understood as a slow widening of where we are able to be. For all of history, we have lived on a single world, and the question tonight is simply which other places, if any, might one day hold us as well. There is no urgency in it. There is only the quiet mapping of the possible, world by world, outward into the dark. So let us begin close to home, with the one other world a human being has ever actually stood upon, and the only one near enough that the journey is counted in days rather than years. It is a place we reached once, long ago, and then left alone for the better part of a lifetime. It is the nearest shore of the wider sea, and for anyone who means to travel farther, it is the natural first step onto that shore. The moon is the only other world any human being has ever touched. Every footprint humanity has left beyond Earth was left there, pressed into grey dust that does not blow away, and those prints remain today exactly as they were made. And yet, for more than half a century after the first visits, no one returned. This was not because the moon grew harder to reach. It was because the reasons to go faded and only slowly began to gather again. The moon has been waiting, unchanged, the whole time. What makes the moon the natural first step is, above all, its nearness. The journey there takes only about 3 days. Every other world we will visit tonight is measured in months, in years, or in far longer spans, but the moon is measured in days. That closeness changes everything about how it could be settled. A colony on the moon could be resupplied from Earth in an emergency. A person in trouble there could, in principle, be brought home. No other destination in this entire journey offers that thin thread of rescue, and it makes the moon less a distant frontier than a shore just offshore of home. For a long time, the moon was thought to be bone dry, and that belief made it seem a poor place to stay. But near its poles, the story turned out to be different. There are craters near the lunar poles whose floors never see the sun at all, tilted so that sunlight has not reached them for ages. Those permanently shadowed floors are among the coldest places in the entire solar system, and the cold has done something quietly valuable. It has trapped water, frozen as ice, and held it there across an unimaginable stretch of time. Hundreds of millions of tons of it may lie waiting in the dark. Water, as we have seen, is never only water. On the moon, it means drinking water for the people who would live there. Split apart by energy, it means oxygen to breathe and hydrogen to burn as fuel. A lunar settlement built beside those icy craters could, in time, supply much of what it needed from the ground beneath it rather than from home. And because the moon sits so near to Earth and so low in the grip of its own gravity, it could become something more than a destination. It could become a refueling stop, a staging post from which journeys deeper into the solar system begin. Beside those dark craters stand ridges that catch almost the opposite fate. They rise high enough that sunlight rarely leaves them, lit for nearly the whole of the lunar day while the crater floors below stay black. A base built on such a ridge could draw nearly unbroken solar power, warming itself and running its machines, while reaching down into the shadow just beside it to mine the ice. Darkness and light lie side by side there, resource and energy within sight of each other. It is one of the few places in the solar system where the geography itself seems to offer a settlement its two most basic needs at once. The moon's gravity is gentle, about 1/6 of the pull we feel on Earth. This has consequences that cut both ways. Leaving the moon costs only a small fraction of the effort it takes to leave Earth, which is what makes it such a natural launching place for journeys onward. But that same lightness is a long-term worry for the body, which evolved under a heavier hand and may not stay strong under so faint a weight across years. A person could move on the moon with an ease that feels almost like flight, and still, slowly, pay a quiet price for it. This tension between advantage and cost will follow us everywhere. Against these gifts, the moon sets hard conditions. There is no atmosphere at all, no air to breathe and none to soften the sky. The sun, when it shines, shines without any veil, and the shadows are absolute. With no air and no magnetic field, the surface takes the full weight of radiation from the sun and from far beyond, along with a constant faint rain of tiny meteorites that strike unslowed. To stand unprotected on the lunar surface for long would be to accept a dose that no body could safely bear. The openness that makes the sky so clear is the same openness that makes it dangerous. For this reason, the real lunar colony would most likely not sit on the surface at all, but just beneath it. A layer of the moon's own soil, piled a few meters thick over a habitat, is enough to turn aside most of the radiation and to blunt the small impacts. There are also natural tunnels to consider, hollow tubes left behind where rivers of lava once flowed and drained away long ago. Some of these lunar tubes are thought to be large enough to hold a small town, with a roof of solid rock overhead. To live on the moon, in the end, may mean to live inside it. The rhythm of the moon is strange to a body tuned to Earth. A single lunar day and its following night together last about a month, so that any given place bakes in sunlight for roughly 2 weeks and then falls into cold darkness for 2 weeks more. The temperature swings enormously between those extremes, a punishing cycle for machinery and for anyone depending on it. This is part of why the poles, with their steady light and steady shadow, are so prized. Away from them, the long day and the long night impose a pace that no clock brought from Earth would quite match. There is the dust as well, which sounds like a small thing and is not. Lunar dust has never been rounded by wind or water, because there is neither. Every grain keeps its sharp, jagged edges, and the whole surface carries a faint electric charge that makes the dust cling. It works its way into seals and joints and the moving parts of machines. It clung to the suits and the tools and the lungs of those who first walked there, and it wears at everything it touches. Living on the moon means living in a fine, sharp, clinging grit that never settles for good, and managing it is one of the quiet, serious tasks of staying. And still, for all of that, the moon holds a distinction no other world in this journey can claim. It is the only place we could settle now, with the tools we already have, requiring no new invention and no distant breakthrough. The water is confirmed. The power is within reach. The trip is short enough to survive a mistake. What has kept us from returning to stay has never really been a matter of capability. It has been a matter of will, of choosing to go. The doorway has stood open the whole time, and the only question the moon quietly asks is whether we ever mean to walk through it. There is a reason the moon feels different from every other world in this journey, and it is not only its nearness. It is the fact that we have already been there. The grey plains still hold the marks of the first visits, the prints and the tracks and the quiet machines left behind, undisturbed by any wind. In a sense, the moon is not an unknown frontier at all, but a place we have touched and then set aside, a shore we walked once and then chose, for a long while, not to walk again. To return to stay would be less a discovery than a homecoming to a place we already know. A settlement there would live under a black sky that never turns blue, with the earth hanging fixed in one place overhead, neither rising nor setting, turning slowly through its phases as the days pass. That unmoving earth would be a strange and constant companion, a blue and white sphere always in the same corner of the sky, near enough to watch the weather moving across its face. No colony anywhere else in this journey would have that comfort, the sight of home itself hanging visible overhead, close enough to reach in only a few days, watching over the first steps we take toward living somewhere other than the world that made us. The moon also offers something no farther world can, a place to learn how to live away from Earth while help is still close at hand. Every skill a wider settlement of space would need could be practiced there first. How to mine ice, how to build beneath a layer of soil, how to keep people healthy in low gravity, how to grow food far from any field. Mistakes made on the moon can be answered in days rather than years, and the lessons learned there would travel outward with us to every harder world beyond. In that sense, the moon is not only the nearest shore, but the first classroom, the place where living elsewhere stops being a theory and becomes a practiced thing. So we leave the nearest shore for now, its craters full of ancient ice, its ridges bright in a black sky, and we turn outward to the world that has held the human imagination more tightly than any other. It is farther, colder, and harder than the moon in nearly every way. And yet it is the one world we have already, in our hearts and in our plans, decided we are going to reach. No world beyond Earth is fixed more firmly in the human imagination than Mars. It has filled more stories, more plans, and more careful designs than every other candidate world combined. Some of that devotion is earned, and some of it is romance, and it is worth holding both gently at once. Mars is not the easiest world to settle, and it is not the safest. It is simply the world that humanity, for reasons both good and beautiful, has already decided it is going to. Tonight we can look at it plainly and let it be exactly what it is. Part of the pull of Mars is that it is, in a few important ways, almost familiar. The Martian day is close enough to our own to feel uncanny. The planet turns once on its axis in a little over 24.5 hours, so that a day there is only about 40 minutes longer than a day on Earth. Human bodies, and the crops we would bring with us, are tuned by long habit to a roughly 24-hour rhythm, and Mars offers that rhythm almost unchanged. Of all the worlds in the solar system, none keeps a clock so close to ours. Mars also holds water, though it holds it frozen. Thick caps of water ice sit at both of its poles, brightening and shrinking with the Martian seasons. Beyond the poles, more ice lies buried just beneath the surface, across wide bands of the planet's middle latitudes, close enough in places that it shapes the ground above it. The water is not liquid, and it is not always easy to reach, but it is present in great quantity. For a world so cold and so dry at first glance, Mars turns out to be quietly generous with the one resource that unlocks all the others. The surface of Mars carries the marks of a wetter past, and those marks are part of what makes it so difficult to look away from. There are dry river valleys that once carried flowing water. There are the flat floors of old lakes, and the fan-shaped spread of ancient deltas where rivers once emptied into standing seas. Long ago, it seems, Mars was a warmer and wetter world, with water moving across its surface under a thicker sky. That history makes the planet almost irresistible to study, and it hints that resources may have been gathered and laid down there over long ages, waiting. The gravity of Mars is a little more than a third of Earth's, which places it in an interesting middle ground. It is stronger than the Moon's faint pull, enough that objects fall with more conviction, and the body has more to work against, and this may prove kinder over long stays. But it is still far below the weight we were made for, and whether a third of Earth's gravity is enough to keep a human body healthy across years or across a life is simply not yet known. Mars sits in the uncertain zone between too little and enough, and only time will tell where exactly it falls. Against these gifts, Mars sets challenges that are easy to underestimate from a distance. The atmosphere, for all that it exists, is almost nothing to breathe. It is made overwhelmingly of carbon dioxide, and it presses on the surface with less than 1/100th of the force of Earth's air. That is not thin air. It is very nearly no air at all, far too little to breathe, and far too little to hold back the radiation from above. Anyone standing on the surface of Mars would need a sealed, pressurized suit at every moment, as surely as if they stood in open space. The radiation on Mars is a constant, patient danger, rather than a sudden one. With no global magnetic field to turn the particles aside, and almost no atmosphere to absorb them, the surface receives a dose far above anything a person would meet on Earth, day after day, without pause. It is not enough to strike anyone down at once. It is enough that a long life spent unprotected on the surface would carry real and growing risk. This is why the honest designs for living on Mars send people underground or behind thick walls for much of the time. The open Martian sky is beautiful and quietly hostile at once. Then there are the dust storms, which set Mars apart in a way few expect. Every so often, a storm swells and spreads until it wraps the entire planet, veiling the whole surface in fine suspended dust for months at a time. During such a storm, the sky dims and the sunlight thins to a weak glow, and this is not merely an inconvenience. For a colony leaning on solar power, a storm that dims the sun across the whole world for the better part of a year is a threat to survival itself. It is one of the main reasons that steady nuclear power, buried and indifferent to the sky, is so often favored for any serious Martian settlement. There is also the plain fact of distance and the isolation it brings. Mars swings nearer and farther as the two planets move along their orbits, and even at its closest, it lies many minutes away at the speed of light. A message sent to Earth may take many minutes to arrive, and the reply as long again, so that no true conversation is possible, only a slow exchange of statements across the gap. A journey home cannot be made whenever one wishes, but must wait for the planets to align, a wait counted in years. A colony on Mars would be, for long stretches, genuinely and completely on its own. When you gather all of this together, a picture of a real Martian colony takes shape, and it is not the picture of open domes under a pink sky. It is a picture of shelter and buried rooms. Habitats would sit under a few meters of soil, or press back into the mouths of caves and lava tubes, using the planet's own mass to hold the radiation at bay. Power would come from compact nuclear sources that do not care whether a storm has darkened the sun. Water would be mined from buried ice and split into oxygen to breathe and hydrogen to burn. From the carbon dioxide of the air, combined with that hydrogen, fuel itself could be manufactured, so that the journey home might be made from the planet rather than carried all the way from Earth. Food would grow under artificial light, in sealed and pressurized greenhouses, in Martian soil carefully cleaned of the harsh compounds that lace it naturally. None of this would be comfortable, and none of it would be simple. But none of it is impossible, and that is the quiet, remarkable truth about Mars. It is a world where a determined settlement could, with care and patience, make nearly everything it needs from what lies around it. The romance of Mars imagines people walking freely under an open sky. The reality of Mars imagines people living cleverly and mostly indoors, and staying alive by their wits and their machines. It is worth being honest about why Mars holds us so tightly, because the reasons are not entirely rational, and that is part of their strength. Mars is the one other world we can picture as a place, with weather and seasons and a surface a person could imagine standing upon. It has a sky that turns colors at dawn and dusk, though the colors are not our own. It has dust that drifts and settles, and frost that comes and goes, and ground shaped by wind and ancient water into forms that feel almost familiar. Of all the worlds beyond Earth, Mars is the one that most looks like somewhere, rather than like the surface of a machine or the inside of a furnace, and that resemblance speaks to something in us that reason alone cannot account for. A colony on Mars would still live mostly indoors and mostly underground, and its people would look out at that almost familiar surface through thick windows, sealed away from an air too thin to breathe. But they would look out at a real horizon, at hills and plains and a distant rise of ground, at a sun that rises and sets on a cycle close to the one their bodies remember. It would be a hard life, and a careful one, and in some quiet way, a recognizable one. That may, in the end, be why we have chosen it, not because it is the easiest world, but because it is the one that most lets us imagine ourselves still being ourselves. Beyond even that reality lies the long dream of terraforming, the slow remaking of Mars into something a person could walk beneath an open sky. The vision is to thicken the atmosphere, to warm the planet, and to let liquid water gather again on its surface. Whether Mars holds enough accessible carbon dioxide to do this at all is a genuinely open question, and even the most hopeful timelines run to centuries or far longer. It is best held not as a plan, but as a distant aspiration, a thing our descendants might attempt across spans of time we can barely picture. For now, Mars remains the world we have chosen, waiting, red and cold, for us to arrive and begin. For a long time, people imagined Venus as Earth's warmer twin. It is nearly the same size as our world, and it hides beneath an unbroken cover of cloud, and into that mystery the imagination poured oceans, jungles, perhaps even life. The first close looks ended that dream entirely, and they ended it without mercy. And yet Venus, of all the ruined worlds in the solar system, may hold one of the most Earth-like environments to be found anywhere off our own planet. The trick, the strange and simple trick, is to stop looking at the ground and to look up instead. The surface of Venus is as hostile as any place we know. It is hot enough to melt lead, and it does not cool at night or near the poles, because the heat is trapped everywhere at once by a runaway greenhouse effect in an atmosphere thick with carbon dioxide. The whole surface sits at that same furnace temperature, always. Nothing we have ever built to land there has survived for long. The ground of Venus is not a frontier to be settled. It is a killing heat that no shelter we can presently imagine could hold at bay for any length of time. The pressure at that surface is its own separate horror. The atmosphere of Venus is so massive that at the ground it presses down with a force one would feel only far beneath the ocean on Earth, as though standing hundreds of meters underwater. The early probes that reached the surface were not merely cooked. They were crushed and silenced within a short while of arriving. Between the heat and the pressure, and clouds of sulfuric acid drifting high above, the surface of Venus earns its reputation completely. Judged by its ground, it is one of the least survivable places in the solar system. But a planet is not only its surface, and this is where Venus quietly turns from a ruin into a possibility. Rise about 50 to 60 kilometers above that burning ground, up into the cloud layer, and the world changes completely. At that altitude, the crushing pressure eases until it is nearly identical to the pressure we feel at sea level on Earth. The furnace heat fades until the temperature settles into a range close to a mild day at home. The radiation, softened by the thick air below, becomes manageable. High above its own inferno, Venus hides the most Earth-like conditions to be found anywhere beyond Earth. How could anyone live in a sky with no ground beneath them at all? The answer lies in a quiet fact about the air of Venus. Its atmosphere is so heavy and so thick with carbon dioxide that ordinary breathable air, the very mix a person needs to live, is lighter than it. On Venus, a bubble of breathable air would float, the way a balloon filled with light gas floats up through the air of Earth. This means that a habitat filled simply with the air its people breathe would rise and drift naturally in that temperate cloud layer. The living space and the lifting force become one and the same thing. Picture, then, a settlement that floats. Great buoyant habitats would ride the winds of Venus at the altitude where the world is mild, held aloft by nothing more exotic than the air within them. Sunlight is strong at that height, pouring down from above and reflecting up from the bright clouds below, so that solar power would be abundant. The temperature would be gentle, the pressure familiar, the light generous. Of all the ways we have imagined living beyond Earth, few are as strange and as oddly pleasant as this one, a city adrift in the high clouds of a planet whose surface would destroy it in minutes. Such floating cities would face real difficulties, and it is only honest to name them. The clouds of Venus are laced with sulfuric acid, and so every surface exposed to them, every habitat wall and every suit, would need a skin that acid cannot eat. There is no solid ground to build upon or to stand on, which means everything must float or be tethered to something that does. And raw materials would be hard to gather, drawn either from the atmosphere itself or hauled up at great effort from the surface far below. These are serious problems. But they are problems of engineering, and engineering is the kind of problem that patience can solve. There is one more thing about Venus that lingers, unresolved, in the high clouds. There have been reports, disputed and argued over, of a certain gas drifting in those clouds, a gas that on Earth is most often tied to living things. The signal has been questioned and re-examined, and it may well have an ordinary explanation in some chemistry we do not yet fully grasp. Nothing about it is settled. But it was enough to make thoughtful people pause and ask, quietly, whether the temperate clouds of Venus are as lifeless as everyone had assumed. It is a small open door, left ajar, and no one yet knows what lies behind it. What makes Venus so quietly remarkable is how completely it was misjudged, and for how long. For generations it was defined entirely by its surface, and by that measure it is nothing but a furnace and a crushing weight, a world written off as impossible. All that time, the most overlooked comfortable zone in the solar system was floating overhead, out of sight to anyone who refused to lift their eyes from the ground. The whole promise of Venus lay in a single change of view, from the surface to the sky. It is a lesson the rest of this journey keeps repeating in different forms. We tend to think of habitability as something a world either has or lacks, printed into its nature. Venus suggests that it can instead be a matter of where, exactly, you choose to stand. The same planet is a death sentence at its surface, and a near-Earth mildness a short way up. To settle Venus would be to live in that thin, kind band between the two, always aloft, always drifting, never once touching the ground. It is one of the more improbable homes in this whole survey, and one of the most quietly hopeful, precisely because it was hiding in plain sight the entire time. It is worth lingering on how completely the idea of a floating city overturns our instincts about where safety lies. On every other world, safety means going down, burrowing beneath the surface, putting mass overhead. On Venus, safety means staying up, never descending, keeping always to the high, mild air and letting the deadly ground fall away below. The danger and the shelter trade places. To live on Venus would be to live in a permanent, gentle flight, held aloft not by machinery straining against gravity, but simply by the nature of the air itself, which lifts a breathable bubble the way water lifts a boat. There is a strange serenity in that image, once the strangeness settles. A city drifting slowly on the winds of another world, warm and bright, its people breathing ordinary air, the burning surface forgotten far beneath the clouds. It would never touch the ground, never come to rest, always moving with the great slow currents of the atmosphere around the planet. Of all the homes we have imagined tonight, it is perhaps the one that feels least like a shelter and most like a kind of sailing, an unhurried, quiet voyage through the high clouds of a world we had written off entirely, going nowhere in particular, in no hurry at all. There is a further reason the clouds of Venus deserve attention, beyond their mildness, and it has to do with how near they are. Venus is one of the closest worlds to Earth, and at times it comes nearer to us than any other planet does. A journey there would be shorter than a journey to Mars, which means that of all the places we have imagined settling, the floating cities of Venus might be among the earliest we could actually reach. The world we wrote off most completely may sit, in the end, among the most accessible, its temperate sky waiting only a modest crossing away. So we let Venus go on turning beneath its clouds, its floating cities still only imagined, its high air waiting mild and bright above a surface no one will ever walk. And we move outward again, past the orbit of our own world and past the red planet we have already claimed in our dreams, into a region most people never think of as a destination at all. There, among a belt of drifting stone, sits a small round world that may matter more than its plainness could ever suggest. Between the orbit of Mars and the orbits of the giant planets lies a wide region scattered with rock and ice, the asteroid belt. It is not the crowded field of tumbling boulders that stories often picture. The belt is mostly empty space, its pieces spread so thinly that a traveler could pass through it and rarely see anything at all. But at its center is a single object large enough to be a world in its own right, round and quiet and unassuming. It is called Ceres, the largest body in the belt, and the only dwarf planet in the inner solar system. Ceres captures no one's imagination the way Mars does. It has no romance attached to it, no long history of stories, no place in the dreams of explorers. It is small, grey, and easy to overlook. And yet, measured against the practical needs of a spreading human presence, Ceres may be the single most useful body between here and the outer planets. Its value lies precisely in the qualities that make it seem dull. It is quiet, it is stable, and it is generous with exactly the resources that a wider settlement of space would need most. The first of those resources is water, and Ceres holds it in astonishing quantity. A large fraction of the whole small world, by volume, may be water ice, locked into its structure beneath a dusty crust. The amount is difficult to picture. It could rival, and perhaps exceed, all the fresh water held on the surface of Earth, gathered into one modest sphere far out in the cold. For a world so small and so far from the sun, Ceres turns out to be one of the great reservoirs of water in the inner solar system, a frozen well waiting at the center of the belt. There are signs that this water is not entirely frozen and still either. Bright patches gleam on the floors of some of Ceres' craters, and these appear to be salts, the kind left behind when briny water rises from below and its liquid slowly departs. That suggests pockets of salty water not far beneath the surface, and perhaps not so very long ago. A world with liquid water moving beneath its skin, even briny and cold, is a world with a quiet inner life, and one that a settlement could tap far more easily than it could carve water out of solid, ancient ice. The gravity of Ceres is so gentle that it changes the whole logic of living there. It pulls with only a few % of the force we feel on Earth, so faint that a person would have to move with care simply to stay on the ground. For long-term health, so little weight is a genuine worry, as it is on every small world. But for the practical business of moving goods, that faint grip is an enormous gift. Lifting water, or fuel, or raw material off the surface of Ceres costs almost nothing compared with hauling it up from any planet. For a world meant to supply others, that shallow gravity is close to ideal. Ceres also sits in a position that no planet could match, at the center of the belt and between the inner and outer solar system. It is naturally placed as a way station, a point where ships bound outward could pause to refuel and resupply, and where materials gathered from across the belt could be brought together. A world does not need to be beautiful to be a crossroads. It needs to be well placed and well stocked, and Ceres is both. In the long imagined future of human movement through the solar system, it falls almost exactly where a hub would need to be. And all around Ceres lies the belt itself, which is a resource on a scale that is hard to hold in the mind. The countless asteroids drifting there hold more metal, more rock, and more frozen volatile material than any civilization could consume across an enormous span of time. Some are little more than loose piles of rubble, and some are solid lumps of metal. Together, they form a supply of raw material without any near limit, scattered across a region so wide that reaching it all would be the work of ages. Ceres is the natural anchor for that whole reach, the still point around which the belt could be worked. A settlement on Ceres itself would most likely be built into the world, or just beneath its surface, using the crust to hold off radiation and the buried ice to supply water, air, and fuel. The faint gravity would make heavy work strangely easy, though it would ask the body to endure a near weightlessness that we do not yet know how to live with for long. It would be less a colony in the open than a warren of sealed rooms within a small frozen world, lit from inside, drawing everything it needed from the ice and stone around it. Plain, practical, and quietly self-sufficient. The belt also invites a different idea entirely, one that steps away from living on any world at all. Rather than settling the asteroids, a spreading civilization might gather their material and use it to build habitats that spin. A great cylinder, turning slowly on its axis, presses everything inside it outward against its inner wall, and that pressing feels, to anyone within, exactly like gravity. A spun habitat could offer the full weight of Earth, made rather than found, and it could be built from asteroid metal and shielded with asteroid rock. The belt would supply the substance, and the spinning would supply the weight that no natural small world can. This is perhaps the quiet significance of Ceres and its belt. They may never be famous. No one may ever dream of them the way they dream of Mars. But they hold the water, the materials, and the gentle gravity well from which a wider human presence in space could actually be supplied and built. Ceres may be remembered in the long run, not as the world that captured anyone's heart, but as the world that quietly made every other colony possible. It is the plain, patient center around which the rest could turn, and there is a certain dignity in that role that the brighter worlds cannot claim. There is a quiet lesson in Ceres that reaches beyond Ceres itself, and it has to do with what we choose to value. We are drawn, always, to the worlds that look like somewhere, the ones with weather and color and the promise of standing beneath a sky. Ceres has none of that. It is a small gray sphere in an empty part of space, easy to pass over, easy to forget. And yet it may hold more of what a spreading civilization actually needs than any of the brighter worlds, because it holds water and materials within an almost effortless reach. The things that matter most for survival are rarely the things that stir the imagination, and Ceres is a plain reminder of that gap. If people ever truly move out into the solar system in numbers, it will not be the beautiful worlds that make it possible, but the useful ones. It will be the quiet reserves of water and metal, the gentle gravity wells that make lifting cheap, the well-placed crossroads where ships can gather and refuel. Ceres is the first of these we have met, and it may be the most important, precisely because it asks for no admiration. It simply sits at the center of the belt, full of ice and stone, waiting to become the plain and patient foundation on which the brighter dreams would quietly have to rest. It is worth adding that the belt offers something no single planet can, which is safety in numbers and in spread. A civilization gathered on one world is a civilization that can be undone by a single disaster. A civilization scattered across 1,000 small bodies and turning habitats, each self-sufficient, each drawing on the same abundant materials, is far harder to bring to an end. The belt invites exactly that kind of spreading, a settlement not of one great place, but of many small ones, distributed across a wide region, quietly independent of any single point of failure. There is a durability in that dispersal that the grander worlds, for all their romance, cannot easily match. We leave the belt now, with its single round world and its endless scattering of stone, and we cross the wide gap toward the giant planets. There the sunlight grows faint, and the cold grows severe, and the worlds worth considering are no longer planets at all, but moons. Around the largest of the planets circles a family of them, several as large as small worlds, and beneath the ice of some lie oceans larger than all the seas of Earth. They are among the most fascinating destinations in the whole solar system. They are also among the most dangerous, and the danger and the promise are woven tightly together. The largest planet in the solar system rules over a family of moons, and to understand why some of them could be homes and others never can, you have to understand the planet's hidden danger. The giant is wrapped in belts of intense radiation, invisible and immense, generated by its powerful magnetic field. Any world that orbits close is bathed in that radiation without pause. Any world that orbits far enough out escapes the worst of it. Among the giant's moons, distance from the planet is very nearly the difference between a place that could hold life and a place that would end it. The outermost of the 4 large moons is a world called Callisto, and it is the safe one. It orbits far enough from the giant planet that it sits beyond the reach of the most intense radiation belts, out where the storm of particles has thinned. The dose it receives is a small fraction of what falls on the inner moons, a difference so large that it changes everything about whether people could live there. For a species that evolved beneath the shelter of a magnetic field and a thick atmosphere, that distinction is not a minor detail. It is very nearly the whole question. Callisto does not announce itself. It has no towering geysers, no cracking and shifting surface, no dramatic features to catch the eye. It is one of the most heavily cratered worlds known, its face marked by an immense age of quiet impacts and almost nothing else. Nothing there is tearing the crust apart. Nothing is erupting or grinding or reshaping the ground. That stillness is exactly what makes it seem dull, and it is also exactly what makes it dependable. A world where nothing violent happens is a world where a settlement could rest without being disturbed. In size, Callisto is a genuine world, roughly as large across as the planet Mercury. It is one of the largest moons in the solar system, big enough to hold real resources and to offer real room. Water ice lies across its surface and mixed through its crust, the same resource that unlocks air and fuel everywhere else. A salty ocean may lie far beneath, suspected though not yet confirmed. Its gravity is gentle, roughly an eighth of Earth's, faint enough to make leaving easy and, as always on these small worlds, faint enough to raise the same unanswered worry about the body over long spans. Because it is both stocked with resources and relatively safe from radiation, Callisto has been studied seriously as a base, a place from which the rest of the giant planet's kingdom could be explored. From a settlement on Callisto, the more dangerous inner moons could be visited briefly and carefully, reached by short journeys, and then retreated from before the radiation gathered to a harmful dose. It could serve as the front porch of the giant world, the one safe foothold from which everything more perilous is approached. Few places in the outer solar system offer that combination of safety and usefulness so plainly. There is something almost restful in Callisto's ancient stillness. Its surface has changed so little across so long a time that it stands as one of the oldest, quietest faces in the solar system, a record of the distant past, preserved by sheer lack of activity. Where other worlds churn and crack and remake themselves, Callisto simply endures, patient and cold, its craters undisturbed. A world like that asks nothing and threatens nothing. It has been waiting, unchanged, far longer than there have been eyes to see it, and it would go on waiting whether or not anyone ever arrived. To live on Callisto would be to live beneath its surface, as on so many of these worlds, using the crust to hold off what radiation does reach it, and drawing water from the ice. It would be a cold and distant home, lit from within, far from the sun, far from Earth, with the enormous banded face of the giant planet hanging always in its sky. But it would be, by the standards of the outer solar system, a stable and survivable one. Among all the moons of the giant, it offers the rarest quality of all, which is simply the freedom from the radiation that makes its brighter siblings so deadly. It is worth pausing on how completely Callisto reverses our usual instincts. The moons that draw the eye and fire the imagination, the ones with hidden oceans and cracking ice, turn out to be the ones that could kill a person fastest. And this plain, cratered, forgettable world, the one no story ever bothered to romance, turns out to be the one where a settlement could actually take hold. The pattern we met at Venus and will meet again returns here in the outer dark. Survivability rarely follows spectacle. More often it hides in the places nobody thought to look twice at. For that reason, Callisto may end up mattering far more than its quietness suggests. If people ever truly live among the moons of the giant planet, they will most likely begin here, on the safe world at the edge of the kingdom, and reach inward from this foothold toward the more tempting and more dangerous places. There is an eerie patience to a world that seems only to be waiting, cold and still and uncommonly survivable, for someone to arrive and make use of it. Callisto has that quality more than almost anywhere else in this journey. It is worth dwelling on the peculiar comfort of a world where nothing happens. We tend to prize activity, movement, and change, and to think of stillness as a kind of emptiness. But for a place to live, stillness is a gift. A world that does not quake, does not erupt, does not crack its crust or shift its ground, is a world a settlement can trust. Callisto offers exactly that trust. Its ancient, cratered face has stayed nearly the same across an immense span of time, and it would go on staying the same long after any colony was built upon it. There is a rare security in that unchanging quiet, and there would be a strange grandeur to the view. From the surface of Callisto, the giant planet would hang in the sky, smaller than from the closer moons, but still enormous, its bands of cloud slowly turning, its great storms creeping across its face. The distant sun would be only a brilliant point, casting long, sharp shadows across the ice. It would be a cold and silent place, lit by a shrunken sun and a giant world, and it would ask nothing of the people who came to it, except that they shelter from what little radiation reached them and draw their water from the ice. Among all the moons of the giant, it is the one that most simply lets a settlement be. Consider what a first foothold on Callisto might actually be like for the people who built it. They would arrive after a voyage of years, into a system ruled by a world so large it carries its own dangers, and they would settle on the one moon where those dangers thin to something survivable. Their days would pass mostly below the surface, in rooms carved into ancient ice and rock, tending the machines that made their air and melted their water. Now and then they would go up to the surface, briefly and carefully, to look out across a plain unchanged for ages beneath a sky that held both a shrunken sun and an enormous banded world. From that quiet base, the rest of the giant's kingdom would lie open to careful study. Short journeys could carry explorers inward toward the more dangerous moons, close enough to learn from and then away again before the radiation gathered to any harm. Callisto would be the safe harbor at the edge of a perilous sea, the place ships returned to and rested, the one dependable ground in a region that otherwise offers none. It is an unglamorous role and a vital one, and it suits the plain character of the world exactly. There is a further quiet advantage to a world so far from the giant's fury, one easy to overlook. Because Callisto is spared the worst of the radiation, the machines a settlement depends upon would last far longer there than on the inner moons, where the constant particles wear at electronics and materials alike. A colony is only as durable as its equipment, and equipment endures where the radiation is thin. On Callisto, the same stillness that protects the people would protect the tools that keep them alive, and that doubling of safety, for flesh and for machinery at once, is worth more than any dramatic feature the inner moons could offer. But we cannot stay only on the safe world, because the moons that draw us inward have their own extraordinary gifts, and the next of them carries something no other moon in the solar system possesses. It is the largest moon of them all, larger even than a planet, and alone among the moons it makes something that everywhere else only planets and stars can make. It generates, from somewhere within itself, a magnetic field of its own. Moving inward from the safe world, we come to the largest moon in the entire solar system. It is called Ganymede, and it is larger across than the planet Mercury, a moon that would be counted a proper world if only it orbited the Sun directly instead of circling a giant. Its size alone would make it worth our attention. But size is not what sets Ganymede apart from every other moon we know. What sets it apart is something invisible, generated somewhere far within it, that no other moon in the solar system possesses. Ganymede makes its own magnetic field. Alone among the moons, it generates a magnetism from within itself, most likely from a core of molten metal turning slowly at its center, the same kind of engine that gives Earth its own protective field. This is genuinely singular. The other moons are bare to whatever their planets and the Sun send their way, but Ganymede raises a field of its own against the dark. When it was first understood that a mere moon could do this, it quietly rewrote what a moon was allowed to be. It would be a fine story if that field made Ganymede safe, but the truth is more complicated and more honest. The field the moon generates is real, but it is weak, far too faint on its own to turn aside the fierce radiation of the giant planet it orbits. Ganymede circles closer to the giant than the safe world does, and so it takes a heavier dose despite its shield. The magnetic field does not make it a haven. What it does is stranger and more interesting. It changes what is theoretically possible, offering at least some measure of homegrown protection that no other moon can claim at all. Beneath its crust of ice, Ganymede is thought to hide an ocean, and the ocean may be immense. Salty water, held liquid far below the frozen surface, could amount to more than all the water on the surface of Earth gathered together. The evidence for it is beautifully indirect. The moon's own faint auroras, glowing where its magnetic field meets the particles around it, shift and steady in a way that betrays a hidden conducting layer beneath the ice, and a salty sea is the natural explanation. A world that makes its own field and hides its own ocean is a rare thing indeed. The gravity of Ganymede is gentle, less than a sixth of Earth's, in the familiar range of these large moons. As always, that faint pull makes leaving easy, and raises the same unresolved question about the body across long stays. But Ganymede's real difficulty is not its gravity. It is the radiation that its weak field cannot fully hold back, the price of orbiting nearer to the giant than the safe world does. To live on Ganymede would mean, once again, to live beneath the surface, letting the ice and rock overhead finish the shielding that the moon's own field begins. And yet the appeal of Ganymede is hard to set aside. It is the largest moon of them all, with room and resources to match. It holds a hidden ocean of extraordinary scale. It makes a magnetic field found nowhere else among the moons. For a settlement willing to accept a harder radiation environment than the safe world offers, in exchange for size, water, and the faint shelter of that unique field, Ganymede is a serious long-term prospect. It sits in the balance between promise and peril, in a way that makes it one of the most interesting worlds in this entire survey. There is a quiet wonder in the fact that a moon should behave so much like a planet. Ganymede has a field like a planet, an ocean like a planet, a size like a planet, and lacks only the independent orbit around the Sun that would let us call it one. It is a reminder that the categories we draw between worlds are looser than they seem, and that grandeur can gather in unexpected places. Around a single giant, a moon has quietly assembled nearly all the marks of a world and hung them in the sky beside its enormous parent. To stand on Ganymede, beneath its ice and behind its faint shield, would be to stand on the largest moon there is, with a buried sea beneath your feet and the banded face of the giant filling the sky. It would be cold and distant and lived in mostly underground. But it would carry a distinction no other moon can offer, the one moon that raises a shield of its own, however slight, against the dark. There is something in that image worth resting on, a small world doing quietly, on its own, what we had thought only planets and stars could do. There is a lesson in Ganymede about how easily grandeur can hide in a category we have already dismissed. We learn early that moons are lesser things, small companions to the real worlds, and we rarely think to look at them closely. And yet here is a moon larger than a planet, with a metal core turning at its center, a field rising from within it, and a hidden ocean beneath its ice that may outweigh all the seas of Earth. It broke, quietly, nearly every rule we thought moons obeyed. It is a reminder that the sky is stranger and more generous than our tidy categories allow, and that the most remarkable places are sometimes the ones we never bothered to examine. It is worth remembering too that Ganymede's faint magnetic field, weak as it is, represents something we have found nowhere else and may prove more useful than its strength suggests. Even a partial shield changes the arithmetic of shelter, letting a settlement spend a little less of its effort holding back the radiation and a little more on everything else. Combined with the ice overhead and the rock below, that homegrown field becomes one more layer of protection in a place that needs every layer it can gather. What the moon cannot do alone, it does in concert with the shelter built upon it, and the sum is a world more livable than its raw exposure would imply. To live on Ganymede would be to live on that overlooked grandeur, beneath its ice and behind its faint shield, on the largest moon there is. The giant planet would fill a great span of the sky, and somewhere far below a settlement's feet, the buried ocean would turn in its darkness, unseen and unreachable and immense. It would be a harder home than the safe world at the edge, its radiation a constant background concern. But it would carry a distinction that no other moon could offer, and there is something in that worth resting on, a small world quietly doing what we had believed only the great ones could. It is worth picturing the sky above a settlement on Ganymede, because it would be a sight without equal. The giant planet would hang enormous overhead, far larger than our own moon appears from Earth, its bands of cloud and its slow storms turning through the long day. Ganymede keeps one face toward its planet as it orbits, so from any given place, the giant would hold nearly still in the sky, a constant and immense presence, brightening and darkening as the moon passed through the planet's shadow and out again. To live there would be to live always beneath that great turning face. And beneath one's feet, unseen, the buried ocean would lie, larger perhaps than all the water of Earth, sealed under a thick shell of ice. A settlement would have no easy way to reach it, and might never try. But its people would know it was there, a hidden sea in the dark below, kept from freezing by the faint warmth of the moon's own interior. There is something quietly moving in the thought of living above so much hidden water, on the largest moon there is, beneath the largest planet there is, so very far from the small blue world where all of it began. Still, for all that Ganymede holds, it is not the moon that most captures the longing of those who study these worlds. That distinction belongs to a smaller sibling, orbiting closer still to the giant, wrapped in a shell of cracked and shifting ice. Beneath that ice lies a sea that may hold twice the water of all the oceans of Earth, kept warm without a single ray of sunlight. It is perhaps the most tempting world in the solar system, and its surface is one of the most lethal places we know. To that strange and beautiful contradiction we now turn. Some worlds are difficult because they are barren, and some are difficult because they are dangerous, and a rare few are difficult precisely because they are so tempting that we can hardly bear to stay away. Europa is one of these. It is smaller than the other large moons of the giant. Its surface, a shell of ice, cracked across with long reddish lines, smooth and bright and strange. Beneath that ice lies what may be the most promising sea in the entire solar system. And above it lies a rain of radiation strong enough to end a human life in a single day. The ocean of Europa is the reason for all the longing. Below a crust of ice lies a sea of liquid water that circles the whole moon, a global ocean thought to hold roughly twice as much water as all the oceans of Earth combined. What keeps it liquid so far from the sun is not sunlight at all. It is the constant flexing of the moon by the giant planet's gravity, which kneads Europa's interior and heats it from within. The sea stays warm because the moon is squeezed endlessly as it orbits. It is warmth drawn from motion rather than from light. There are signs that this hidden sea occasionally touches open space. At times, tall plumes of water vapor appear to rise from the surface, venting up through cracks in the ice and carrying material briefly out into the dark before falling back. If those plumes truly rise from the ocean below, they offer something remarkable, a way to sample the buried sea without ever drilling through the kilometers of ice that seal it. Whatever the ocean holds might be lifted, now and then, to the surface on its own, delivered up through the cracks by the moon itself. But the same closeness to the giant that keeps the ocean warm makes the surface deadly. Europa orbits within the most intense part of the giant planet's radiation belts, and the particles fall on its icy face without pause. The dose at the surface is strong enough that an unprotected person would receive a fatal amount within roughly a single day. This is not a slow and patient danger like the radiation of Mars. It is swift and absolute. The surface of Europa is one of the most radiation-blasted places we have ever measured, beautiful to look upon and impossible to stand upon unshielded. So Europa presents us with a genuine contradiction, a world that offers the richest sea in the solar system behind one of the most lethal doors. If people ever go there, they will not live on the surface. They would have to shelter beneath the ice itself, letting the frozen crust above them absorb the radiation or burrow into whatever protection the moon allows. To reach the ocean would mean passing through the very shield that makes reaching it survivable. Everything valuable about Europa lies on the far side of the thing that makes it dangerous, and there is no way to have one without the other. For this reason, Europa is likely to be treasured long before it is ever settled. It is a world we will want to study with enormous care, to understand its ocean and to learn whether that warm and lightless sea holds anything stirring within it. It may be visited, sampled, and watched over for a long age before anyone seriously proposes to live there. It belongs in this journey less as a home than as the ocean world we most want to reach and least want to stand upon, a prize held behind a wall of radiation that we approach with equal parts longing and caution. There is a strange beauty in the idea of that sea, kept warm in total darkness by the pull of a giant world, circling on beneath its ice whether or not anyone ever comes. It has been there, most likely, for an enormous span of time, stirred by tides it cannot feel, sealed away from the sky above. Of all the hidden places in the solar system, Europa's ocean may be the one that most quietly holds our attention, precisely because we cannot easily reach it, and because we do not yet know what, if anything, moves in its depthless dark. Across the moons of the giant planet, then, a single lesson keeps returning, and it is worth naming softly one last time. The most spectacular world, Europa with its buried sea, is the hardest to live upon. The plainest world, the cratered and silent safe one at the edge, is the easiest. Between them lies the great moon that makes its own field, harder than the one and safer than the other. Spectacle and survivability run in almost opposite directions here, as they did at Venus, and as they will nearly everywhere. It is radiation, not beauty, that draws the line between a home and a grave. It is worth sitting a moment longer with the strangeness of a warm sea in a place the sunlight barely reaches. We think of warmth as something the sun gives, poured down from above onto a waiting world. Europa's ocean is warmed from the opposite direction, from within, by the endless flexing of the moon as the giant planet pulls it one way and then another. The heat rises from the rock at the bottom of the sea, not from a sky the water has never seen. It is a warmth drawn entirely from motion, from the patient squeezing of a whole world, and it has most likely kept that ocean liquid across an enormous span of time. Whatever exists in that lightless sea, if anything exists there at all, would have grown up knowing nothing of the sun. It would live by the heat and the chemistry rising from below, in a darkness absolute and unbroken, beneath a ceiling of ice it could never pass. We do not know whether the ocean holds anything more than warm and stirring water, but the mere possibility is enough to make Europa one of the places we most want to understand, a sealed and patient sea turning in the dark, holding its secret quietly, whether or not we ever find a way through the ice to learn it. It is worth being clear that Europa may never truly be a home at all, and that this does not diminish it. Some worlds are meant to be lived upon, and some are meant to be understood, and Europa belongs firmly to the second kind. Its value is not that people might settle it, but that its buried sea is one of the few places within reach where the conditions for life, as we understand them, might quietly exist. A warm ocean, held liquid across ages, stirred by the pull of a giant world, sealed beneath protecting ice. If life arose there, it would have arisen entirely on its own, in the dark, with no knowledge of any world but its own. That possibility gives Europa a different kind of importance than the worlds we might colonize. It is a place we would approach with great care, not to claim it, but to learn from it, and perhaps to leave it largely undisturbed. The instruments we send would be cleaned of every trace of Earth, so that whatever they found beneath the ice would be Europa's alone. It is a world held at a respectful distance, more a question than a destination, its sealed ocean turning quietly in the dark, while we wonder, from far above the ice, what if anything moves within it. It is worth noticing how Europa completes a pattern that runs through the whole giant kingdom, and through much of this journey. The three moons we have met form a kind of scale, from the safe and plain world at the edge, through the great shielded moon in the middle, to the tempting and lethal ocean world closest in. Safety and spectacle run in opposite directions across that scale, exactly as they did at Venus, exactly as they will nearly everywhere. The lesson settles quietly into place here. What draws the eye is rarely what keeps us alive, and the places worth living are seldom the places that first take the breath away. We leave the giant planet's kingdom now, its safe world and its shielded moon and its lethal ocean all turning together in the dark, and we travel farther still, out to the next giant and its most extraordinary moon. There, at a distance where the sun is only a bright point among the stars, lies a world unlike any other we have met. It has a thick sky. It has weather. It has rain that falls and rivers that run and seas that gather at its poles. And of all the strange destinations in this journey, it may be, quietly, the gentlest. Far out among the moons of the ringed giant is a world called Titan, and it is unlike anywhere else we will visit tonight. It is the only moon in the solar system wrapped in a thick atmosphere, and apart from Earth itself, it is the only world known to have stable liquid pooling on its surface. In some ways, it is the strangest destination in this whole survey. And in others, once you understand what its thick air quietly provides, it may be the most welcoming of them all, the one world where the great enemies of space are held at arm's length by the moon itself. Titan is wrapped in a hazy, orange atmosphere, made mostly of nitrogen, the same gas that makes up most of the air we breathe on Earth. But the air of Titan is thicker than ours, pressing on the surface with about half again the force we feel at sea level. That thick blanket of air, together with the moon's great distance from the sun and its own bulk of ice and rock, shields the surface from radiation remarkably well. And it means something no other airless world can offer. On Titan, there is no vacuum pressing against the walls. A person there would not need a suit to hold back the emptiness of space, because at the surface, there is no emptiness. There is only the cold. And Titan has weather, not as a turn of phrase, but truly, in a way found nowhere else beyond Earth. Clouds gather in its sky. Rain falls from them and runs in rivers across the surface, carving channels and gathering into great seas near the poles. But the liquid is not water. It is methane and ethane, cold hydrocarbons that on Earth we know only as gases, but which on Titan's terrible cold flow as liquids do. They rise into the sky, form clouds, fall as rain, run to the seas, and evaporate again, cycling the way water cycles on Earth. Titan is the only other world with that kind of open, moving, falling liquid on its surface. The pressure on Titan is friendly, but the air itself is not breathable. It is nitrogen and methane, with no free oxygen at all, so a person there would still need to carry oxygen to breathe. But consider what they would be spared. There would be no fight against a vacuum trying to pull the air from their lungs and the shelter from around them. There would be no crushing weight as on Venus, and no near-nothing thinness as on Mars. The pressure would be close enough to home that only the cold and the lack of oxygen would stand between a person and the open air. On the scale of hostile worlds, that is a remarkably short list. The cold, though, is severe beyond ordinary imagining. Titan is so far from the sun and so cold at its surface that water ice there is not a soft or melting thing, but a solid as hard as stone. On Titan, water ice takes the place that rock takes on Earth. The mountains and the bedrock are made of frozen water, hard and permanent, while the rivers and seas are made of the hydrocarbons that pour from its sky. It is a world built inside out from the one we know, its water turned to stone and its fuel turned to sea, all of it held in a cold so severe it reshapes what every substance is allowed to be. Yet in that cold, a slow chemistry is at work that makes Titan quietly fascinating. The air rains down complex molecules built of carbon, the same family of chemistry that on the young Earth eventually led toward life. Across its whole surface, in its hazes and its seas and its frozen dunes, Titan is running an unhurried experiment in the chemistry of carbon, cold and patient, and on a scale of a whole world. No one knows where that chemistry leads, or whether it leads anywhere at all. But it makes Titan not only a possible home, but a place of genuine scientific longing, a world doing something we do not yet understand. To settle Titan would be to face a different problem than every other world here, and a simpler one in its way. Because the thick atmosphere already blocks much of the radiation, and because there is no vacuum to hold back, a habitat on Titan could concentrate on the single great enemy, the cold. Insulation and warmth rather than heavy shielding and pressure walls would be the first concern. That is a genuinely different kind of engineering than living on the Moon or Mars demands, and in some ways, a gentler one. Keep the heat in, and much of the rest of Titan is almost accommodating. Titan is also awash in fuel, and offers one of the strangest delights in the solar system. Its seas and its air are full of hydrocarbons, which are natural fuel wherever oxygen can be supplied to burn them. And in that thick air and gentle gravity, a person could strap a pair of wings to their arms and fly by their own muscle, flapping through the orange sky the way a bird flies through ours. Few facts capture the quiet strangeness of Titan better than that. It is a world where a human being, given warmth and air, could take to the sky under their own power, over seas of liquid methane, beneath a haze that hides the stars. Titan's one great drawback is simply how far away it lies. At the distance of the ringed giant, the sun is only a bright star, and its light is far too weak to power a settlement, so any colony there would lean on nuclear warmth and light carried from home or made on site. And the journey to reach Titan is long, a voyage of years, so that it is a world one commits to entirely rather than visits. It sits at the far edge of what we could presently imagine reaching, a distant and demanding destination whose gentleness, once arrived at, might almost make the crossing worth it. For all its cold and all its distance, Titan may be the most quietly welcoming world in this entire journey. It has a sky overhead and weather in its air. It has seas on its surface and no vacuum pressing at the walls. It has fuel in abundance and a gravity soft enough to fly in. The one thing it asks is that you keep out the cold, and everything else it very nearly provides. It is a fitting place to rest near the end of our tour through the solar system, the world where the enemies of space grow fewest, waiting far out in the dark beneath its orange haze. It is worth pausing on how much Titan turns our expectations around. We set out expecting the outer solar system to be the harshest region of all, and in most ways it is, colder and darker and farther than anywhere else. And yet here, at that far remove, is the one world besides Earth where a person could stand in the open without a pressure suit, under a real sky, beside real seas, and face only the cold. The very distance that makes Titan so hard to reach is part of what makes it so gentle once reached, for its thick air and its great store of chemistry are gifts the inner, sunnier worlds do not offer. It is a reminder that hostility and welcome are not always where we expect to find them. There is a quiet beauty in the picture of it too, that lingers after the facts have faded. A hazy orange sky, dimly lit by a distant sun. Rain falling slowly in the thick air, gathering into rivers that wind towards seas of pale liquid. A person moving lightly in the low gravity, perhaps rising on wings into that heavy air, over a shore that no eye had ever seen before. Of all the worlds we have imagined tonight, Titan may be the one that most rewards the imagination, not because it is easy, but because it is so unlike anywhere else, and yet so strangely, quietly livable beneath its haze. But the worlds of our own sun are not the end of the question. The same longing that carries us from the moon to Mars to the moons of the giants reaches farther still, past the edge of the solar system entirely, to the planets that circle other stars. There are worlds out there that look, from a distance, like promising second Earths. And the difficulty with them is no longer whether such places exist. It is whether we could ever reach them, and whether they are as kind as they first appear. Every world we have visited so far circles our own sun, held within the single small system we call home. But the stars themselves are suns, most of them with worlds of their own, and the question of where else we might live does not stop at the edge of our system. It reaches outward to those other suns and their planets. And the natural place to begin is the closest of them all, the nearest star to our own, and the world that turns out to circle it, waiting just beyond the edge of everything familiar. The nearest star to the sun is a small, cool, dim star, far fainter than our own, and around it moves a planet a little more massive than Earth. That planet orbits within the zone where, in principle, liquid water could exist on a surface, neither boiled away nor frozen solid. It is the closest world of its kind that we know, a rocky planet in the comfortable zone of the very nearest star. When it was first confirmed, it carried a quiet thrill, the sense that the nearest possible second home was not somewhere far across the galaxy, but right next door, circling the closest light in our sky. And yet next door, in the language of the stars, is still almost unthinkably far. The light from that nearest star takes years to cross the distance to us, and light is the fastest thing there is. A journey there with any craft we can presently build would not take years but many thousands of years, longer than all of recorded history several times over. The nearest world beyond our sun is close only by the standards of a universe in which nearly everything is impossibly far. In any human sense, it remains profoundly, achingly out of reach. The trouble with that world is not only its distance, but the star it circles. Small, cool stars of that kind are restless, and they unleash powerful flares, sudden floods of radiation far more violent than anything our steady sun sends out. A planet orbiting close to such a star, as this one does, would be bathed in those flares again and again across the ages. Over long spans of time, that radiation can strip a planet's atmosphere away entirely, peeling off the very air that any life or any settlement would need. Whether this world still holds an atmosphere at all is unknown, and it may well have been scoured bare. There is another difficulty, stranger and quieter. Because the planet orbits so close to its dim star, it very likely keeps one face turned always toward that star, and the other turned always away, the same way our moon keeps one face always toward Earth. If so, one side of the world would lie in endless day, and the other in endless night, with fierce differences between them. Whether a stable, livable band could exist somewhere between the burning day side and the frozen night side is simply not known. It is one more open question hanging over a world we can barely see. So this nearest of exoplanets sits before us as a genuine puzzle, tantalizing and unreadable at once. It is either the most tempting address in all the sky, a rocky world in the comfortable zone of the very nearest star, or it is a scorched and airless rock stripped bare by a violent sun. From where we stand, with the instruments we now have, we genuinely cannot tell which. The same world holds both possibilities at once, and until we can look far more closely, it will keep them both, hovering between hope and disappointment in a way we have no present means to resolve. People have imagined ways to cross that impossible gap, and the most remarkable of them abandons the idea of a great ship entirely. Instead of sending something heavy and slow, one proposal would send something almost weightless and very fast, a tiny probe pushed by the pressure of powerful light until it flew at a large fraction of the speed of light itself. A craft like that might cross to the nearest star, not in thousands of years, but in a few decades, arriving within a single human lifetime. It would carry no people, only instruments, but it could send back the first true look at a world around another sun. Even that daring idea, though, would only send a sliver of machinery, not a settlement, and not a soul. To move people across such a distance remains far beyond anything we can do, a challenge that may require patience measured not in years or decades but in generations, or inventions we cannot yet picture. The nearest star's world is best understood, for now, not as a place we are going, but as a marker of how the question changes once it leaves our own sun behind. Out here, distance stops being a difficulty and becomes very nearly a wall. And still there is something steadying in simply knowing that world is there. The nearest star is not barren. It carries at least one world in the zone where water might gather, close enough that we have already imagined the first machines that might one day visit it. Whether it is a ruin or a refuge, it exists, and it circles the closest light to our own, patient and unreachable, holding its answer until we find some way to draw close enough to read it. That knowledge alone quietly enlarges the sky. It is worth feeling, for a moment, the full weight of what that distance means, because it is easy to say the words and miss the truth in them. The nearest star is so far that if you set out toward it at the speed of our fastest craft, you would travel for longer than farming, writing, and cities have existed on Earth and still not arrive. Everything we have ever done as a species would fit many times over inside the span of that single journey. The gap between the stars is not merely large. It is of a different order than any distance human life has ever had to reckon with. And yet we have already begun to imagine crossing even that. The idea of a tiny craft pushed by light to a fraction of light's own speed is not a fantasy but a serious proposal, studied by serious people, however far from ready it remains. It would carry no colonists, only a whisper of instruments, and it would take decades even so. But it marks something quietly significant, the first moment our kind has looked at the distance between the stars and begun, however faintly, to imagine a way across it. That alone changes our relationship to the nearest world beyond the sun, from something purely unreachable to something merely enormously far. It is worth resting for a moment on how recent all of this knowledge is. For nearly the whole of human history, no one knew whether any star but the sun held worlds at all. The planets of other stars were a matter of pure supposition, hoped for but never seen. Only lately have we learned to find them, and among the very first we found was this one, circling the closest star to our own. That the nearest star should carry a world in the zone where water might gather is a piece of fortune we had no right to expect, and it arrived almost as soon as we learned how to look. Whether that world is a ruin or a refuge, its nearness gives it a particular hold on the imagination. It is the first place we would look toward if we ever meant to leave the sun behind, the natural first target of any dream of reaching another star. It hangs there in the dark, at the very edge of our reach and just past it, close enough to name and to study and to wonder about, far enough that no one alive tonight will ever know its answer. There is a quiet ache in that, and a quiet wonder too, that the nearest other world should be so near and so impossibly far at once. Beyond that nearest star lie others, and among them are worlds that in some ways look even more like home. There is a small star, not far as these distances go, circled by a whole family of Earth-sized worlds. And there is a distant world that orbits a star, almost exactly like our own sun. To those we turn now, the further Earths, real and confirmed and impossibly far, the proof that worlds like ours are not rare at all, only distant. Beyond the nearest star, the search for other worlds has turned up something that would have seemed impossible not long ago. Worlds roughly the size of Earth, orbiting in the comfortable zones of their stars, are not rare accidents scattered thinly across the galaxy. They are common, and among the many that have been found, a few stand out, worlds close enough or Earth-like enough to have earned a special place in our imagining of where, someday, humanity might reach. Tonight we visit two of them, and then we let them widen into the larger truth they point toward. The first is not a single world, but a family of them. Not far away, as the distances between stars are measured, a small and cool star is circled by 7 worlds, each of them roughly the size of Earth, all of them packed close around their dim sun. Several of these worlds orbit within the zone where water might be liquid, which makes this one small system one of the richest collections of possibly habitable worlds we have ever found gathered in a single place. Around one faint star, 7 Earth-sized worlds turn, several of them in the gentle band where water could pool. One of those 7 stands out from the rest. It is close to Earth in size, and it receives a little more than half the light that Earth receives from the sun, placing it comfortably within the range where a temperate world might exist. Of all the worlds in that crowded little system, it may be the most Earth-like, and it orbits a star near enough that we can imagine, if only barely, reaching it in some far human future. Whether it holds an atmosphere is being studied even now, with the answer not yet in. It hangs before us as a real and specific hope, a particular world we can point to and wonder about. But that world and all its siblings share the same shadow that fell over the nearest star's planet. They orbit a small, cool star, close in, and so they very likely keep one face turned always toward their sun. The promise of 7 Earth-sized worlds is real, and so is the uncertainty that comes with a dim and possibly restless star, and the likelihood of a permanent day side and a permanent night side. As with so much out here, the closer we look, the more the simple hope resolves into a careful, patient set of questions we cannot yet answer. The second world is different in almost every way, and it fills in the other half of the picture. Far more distant than the family of 7, it orbits a star much like our own sun, a steady yellow star of the same kind that has warmed the Earth across all of its history. The world circles that familiar star at close to the distance Earth orbits our own, taking a little over a year to complete each pass. Of all the worlds found so far, its star is the most like home, and that resemblance gives it a particular pull on the imagination. But this distant world is larger than Earth, noticeably so, and that size comes at a price. If it is a rocky world, its greater mass would give it a surface gravity, perhaps around twice that of Earth. Every step there would feel like carrying the weight of a second body, every motion heavier, every stare a labor. Its star is older and brighter than our sun, and the world sits near the warm inner edge of the comfortable zone, receiving a little more light than Earth does. It is Earth-like in its situation, but not in the ease of standing upon it. And it is unreachably far, farther by far than anything else we have named tonight. It lies well over 1,000 light-years away, a distance so great that the light we see from it now left before much of human history had happened. At the speed of our fastest spacecraft, the journey there would take longer than our species has existed on Earth. It is not a destination in any practical sense. It is something else, a proof, standing far off in the dark, that worlds close to the size of Earth do circle stars close to the kind of the sun. It shows us that such places are truly out there. That is the real discovery, in the end, and it is larger than any single world. It is not this planet or that one, but the sheer number of them. When we survey even a small patch of the sky with care, we find thousands upon thousands of worlds, and from that count we can reckon the whole. Earth-sized planets in the comfortable zones of their stars are not scattered rarities. They number in the billions across our galaxy alone. The night sky, which looks so empty, is quietly crowded with worlds, most of them forever beyond our seeing, all of them simply there. This changes the shape of the question entirely. For most of history, we could wonder whether any world like ours existed anywhere else at all. Now we know that they exist in their billions, and the difficulty has moved. It is no longer whether there are places that could hold us. It is whether we will ever develop the means to cross the distances that separate us from them, before we exhaust the one world we already have. The universe has not been stingy with possible homes. What it has placed between us and them is distance and time. It is worth holding, gently, the difference between knowing a world exists and being able to reach it, because the two have never stood so far apart as they do here. We can name these distant Earths, measure their sizes, reckon the warmth of their light, and still stand no closer to setting foot upon them than a person gazing up at a star stands to touching it. They are real in every way that matters to knowledge, and unreachable in every way that matters to travel. It is a strange new place for our kind to find itself, rich in worlds and poor in any means of crossing to them. And yet even that gap may not be permanent. What is impossibly far tonight was, not long ago, entirely invisible, and what is invisible tonight our descendants may learn to see, and perhaps, in some far age, to reach. We are very early in this. We have only just learned that the worlds are there, only just begun to imagine the first faint machines that might cross to the nearest of them. The distant Earths are not a promise and not a plan. They are simply a truth, newly known, that the sky is full of places like our own, waiting in the dark for a species still learning how to look at them. It helps to understand how these distant worlds are found at all, because the method is quietly humbling. We rarely see the planets themselves. They are far too faint, lost in the glare of their stars. Instead, we watch the stars and wait, and notice the tiny dimming that occurs when a world passes in front of one, blocking a sliver of its light. From that faint and regular flicker, repeated over many passes, we can reckon a world's size, its year, and the warmth of the light it receives. Nearly everything we know about these far planets we know from shadows, from the small and patient dimming of distant suns. That we can learn so much from so little is a quiet marvel in itself. From a flicker of light that left its star before we were born, we can say that a world is out there, roughly the size of our own, receiving roughly the light our own receives, turning around a sun we will never visit. We cannot see its surface, or know its weather, or say whether anything lives upon it. But we know that it is there, and where, and how large, and that is enough to fill the sky with worlds it had always seemed to lack. The dark between the stars turns out to have been crowded all along, and we are only now learning to read it. There is something steadying in that, if it is held gently rather than as a warning. The homes are out there, in numbers beyond counting, real and confirmed, and turning around their stars whether or not we ever arrive. We are not alone in the sense that matters least and most at once, surrounded by worlds we cannot reach, aware for the first time of just how many there are. The sky is full of far Earths, patient and distant, and simply knowing they are there changes how empty the dark can feel. They ask nothing of us tonight. They only wait in their billions, across a distance and a span of time we have only begun to imagine crossing. We have come a long way tonight, outward from the ground beneath us to the far worlds of other stars, and it is worth gathering the whole journey into a single quiet shape before we let it go. The worlds we have visited tell one story between them, told in different voices. Some could hold us soon, and some could hold us only in a future we can barely picture, and a few we may never reach at all. But together, they map the narrow set of places where a hard universe would allow us, with care and patience, to live. The nearest of them, the Moon, could be settled now, with the tools already in our hands. It asks for no invention we do not have, only the will to return and stay. Beyond it, the next few worlds lie within reach of the coming ages, each demanding that we live cleverly rather than comfortably. On Mars, we would live buried against the radiation and the storms. In the clouds of Venus, we would live aloft, drifting above a surface that would destroy us. On Ceres and among the belt, we would live within the ice and stone, or inside slowly turning drums of our own making, borrowing the weight that no small world can give. Farther out, the moons of the giant planets ask still more of us, and offer hidden oceans in return. On the safe and cratered world at the edge of the giant's kingdom, a settlement could rest beyond the reach of the worst radiation. On the great moon that makes its own faint field, we could live behind ice and behind that slender shield at once. And near the lethal beauty of the ocean moon, we would shelter beneath the very crust that makes its buried sea so hard to reach. Each of these worlds is a lesson in living behind something, in putting the world itself between us and the dark. Then there is Titan, far out beneath its orange haze, the gentlest of the difficult worlds, where the only real enemy is the cold. And beyond the reach of our own sun entirely lie the worlds of other stars, the nearest one hovering between hope and ruin, the family of 7 around their dim sun, the far Earth around a star like our own, and behind them, the billions more we have learned must be out there. Real and confirmed, and almost all of them forever beyond our reach, they widen the sky into something crowded and quiet at once. Through all of it runs a single thread, and it is worth carrying with you as everything else grows soft. Almost nowhere is the surface the answer. On nearly every world we visited, the place worth living was somewhere else. It was down in a shadowed crater where ice had waited through the ages. It was beneath a few meters of soil where the radiation could not follow. It was high in a burning sky, or far below a shell of ice, or sealed inside a spinning drum of borrowed weight, or in a warm room kept against a cold that turns water to stone. To leave Earth, then, is not to find another Earth. It is to learn to make small, careful shelters in the few sheltered corners a hard universe allows. It is to carry the essential things with us, the air and the water and the warmth and the weight, and to build around them wherever the radiation thins and the resources gather and the cold can be held at bay. There is nothing frightening in that, once the alarm drains out of it. It is only what living beyond home would truly ask, and it asks it patiently, of a species willing to learn. And there is something restful, in the end, in how little hurry any of it is in. The moon has kept its ice through ages beyond counting, and it will keep it a while longer. The clouds of Venus have drifted mild above their inferno since long before anyone thought to look up at them. The ocean beneath Europa's ice has turned in its darkness for an enormous span of time, stirred by tides it cannot feel. None of these places is going anywhere. None of them needs us to arrive tonight, or this year, or in any span we would recognize. They have waited a very long time, and they are content to wait. So let the far worlds drift now out of reach, and let the one beneath you hold you where you are. You do not need to travel anywhere tonight. You do not need to solve the distance, or beat the clock, or choose which world might one day be a home. All of that can rest. The worlds will keep turning without you, the cold craters and the buried rooms, the floating cities and the seas of dark liquid, all of them patient, all of them in no hurry at all, exactly as they have been for ages before this night, and will be for ages after it. Let your breathing slow now, and let it grow even and unhurried, like the slow turning of a world around its star. Let the reach of space, which we have crossed together in imagination tonight, fold back down to the quiet size of the room around you. There is nowhere you need to be, and nothing you need to carry, and no journey left to make before morning. The far worlds are safe in their distances, and you are safe here, held by the one world that never asked you to leave it. It may be that the truest comfort in all of this is not any single world, but the simple abundance of them. For most of the long human story, we imagined ourselves alone on the only world there was, with nothing but empty dark beyond the sky. Now we know that the dark is full. There are worlds enough to occupy the imagination for as long as our kind endures, near ones we might reach within ages we can picture, and far ones we may never touch, all of them real, all of them turning quietly around their stars. Whatever becomes of us, we live now beneath a sky we know to be crowded with places, and that knowledge alone is a kind of company. And none of it is urgent tonight. The worlds have waited across spans of time that make a human life seem no longer than a single breath, and they will go on waiting, patient and unhurried, long after this night has been forgotten. There is no race to run before morning, no distance you must cross, no choice you must make about which far world might one day be a home. All of that belongs to ages beyond this one. Tonight there is only the quiet, and the slow turning of the worlds in the dark, and the soft weight of the single world beneath you that has always, without asking anything, held you exactly where you are. There is a kind of peace, in the end, in being the world that was left behind. All night we have traveled outward in the imagination, to ice and cloud and hidden sea, to worlds near and impossibly far. And all night the world beneath you has simply held you, asking for nothing, the way it always has. It is the one place in all of this that needed no shelter built, no air manufactured, no cold held at bay. It is the world that was already home before the first of us ever looked up and wondered what else was out there in the dark. Rest now. Let the moon keep its ice, and Mars keep its buried water, and Titan keep its seas beneath the haze, all of them turning on without you in the long and patient dark. Let the distant Earths wait among their stars, in numbers beyond counting, asking nothing. And let yourself settle down at last into the one world that made you, the one place in all of it that was always, quietly, home. Sleep well, and good night.